Hi, we are now on the mathematics of graphs and we'll be discussing graphs and Euler circuits. So let us now have the introduction to graphs. Think of all the various connections we experience in our lives. Friends are connected on Facebook, cities are connected by roads, computers are connected across the internet. We have here what we call the graph theory, and it is a branch of mathematics that illustrates and analyzes connections such as this. In figure 5.5, this is a diagram that could represent friends that are connected on Facebook. So each dot represents a person. You have James, Heather, Juan, Jared, Lisa, and Amy. And the line segments connecting two dots means that those two people are friends on Facebook, like James friends with Heather, Heather friends with Yuan, and then Juan friends with Jared, and Jared friends with James. Another is Lisa friends with Heather, while Heather friends with Amy, and Lisa also friends with James. Now, this type of diagram is called a graph. Now, a graph is a set of points called the vertices, and the line segments that connect each vertex is called edges. Now, let us have some examples. So, the following table lists 5 students at a college, and X indicates that the 2 students participate in the same study group. So, math is with Amber and Laura. Amber is with Matt, Oscar, and Laura, while Oscar is with Amber and Kayla. Laura is with Matt and Amber, and Kayla is with Oscar. Now, what are we going to do? First, you have to draw a graph that represents this information where each vertex represents a student and an edge connects two vertices if the corresponding students study together. And another is you have to use your graph to answer the following question. So first is which student is involved in the most study group with the others. Another is which student has only one study group in common with the others. Next is how many students does Laura have in common with the others. So first is we have to draw 5 vertices, right? So we have Math, Amber, Oscar, Laura, and Kayla. So in any configuration you wish. To represent these 5 students and connect vertices with the edges according to the table, where Math is with Amber and Laura, while Amber is with Math and Oscar and Laura, while Oscar is with Amber and Kayla, and Laura is with Amber and Math. Now, the vertices corresponds to Amber is connected to more edges than the other. As you can see in here, Amber has how many? So we have, let us have another color with this one. We have Math, Oscar, and Laura. So she has 3, while Kayla is the only student with one study group in common because we have Kayla only group with Oscar, and Laura vertex is connected to 2 edges, so she shares 2 study group with the others. So we have Laura here, we have with Amber, and with Math. Okay, so in general, a graph can include vertices that are not joined to any edges, but all edges must begin and end at vertices. If 2 or more edges connect the same vertices, they are called multiple edges. If an edge begins and ends at the same vertex, it is called a loop. Again, same vertex. A graph is called connected if any vertex can be reached from any other vertex by tracing along edges. Essentially, the graph consists of one piece. A connected graph in which every possible edge is drawn between vertices without any multiple edges is called a complete graph. Now let us have different examples. So on the first graph, this has 5 vertices but no edges, so these are not connected. While on the second graph, this is a connected graph that has a pair of multiple edges. Note that the 2 edges across the center, 1 and then 2. There is no vertex there, right? On this part, in the center. Unless the dot is thrown on the edge, if we draw an edge here, this will be considered to pass over each other without touching. Okay? And then next is we have this graph, wherein this graph is not connected. It consists of 2 different sections. We have here 1, and then this is the other one. It is also contains loop. Okay, the edge connected to one vertex. And then lastly, this graph is a complete graph with 5 vertices. So we have 1, 2, 3, 4, and then 5. And they are connected to one another. Take a look. Okay. So for more understanding, like for example, this one, is the graph a complete graph? So our answer is no. It is because we could still have this and then this one connected to one another for us to say that this graph is a complete graph. Okay? Now, consequently, the 3 graphs shown below are considered equivalent graph because the edges form the same connection of vertices in each graph. Like for example, this B. B is connected to A, connected to C, D, and E. While in here again, B is connected to A, and then we have C, D, and then E. Also here, connected to A, C, D, and then E. So they are equivalent graphs. So determine whether the following 2 graphs are equivalent. So despite the fact that the 2 graphs have different arrangement of vertices and edges, they are equivalent. So how can we say so? As you can see in here, to illustrate, we examine the edges of each graph. So the first graph contains 6 edges. Is that 6? So we have here 1, 2, 3, 4, 5, and then also we have 6. And then in the second one, we also have 1, 2, 3, 4, 5, and then 6. So we also have 6 edges. Wherein the edges are AC. Let us see if it is the AC. Let us erase this first. And let's have this part, AC. So we have here AC, and then AE, and then BD. We have BD, BD, BE, CE, and also DE. Okay, same with the other one. If we have there AC, AC, AE, BD, this one BE, and then CE, and also DE. So they are equivalent. If we do the same with the second graph, we can see also that they have the same 6 edges. right? So, because the two graphs represent the same connections among the vertices, they are equivalent.